In this short video, I'd like to show you the main features of Dr. Locansolan's GeoDa program and illustrate how it is used to draw a simple choropleth or area value map. You should have already downloaded, registered and installed your copy of GeoDa. So all we have to do first of all is start it running by double-clicking on the exec file that we'll have somewhere on our system. So I'll do that now. We get a message saying it may be potentially unsafe. I wouldn't worry about that. We fire it up. And you see that what happens is that we get this rather interesting toolbar which appears. This is a change from the previous versions of OpenGeoda in that all that we see are the menu items. And we've got a series of possibilities from file through to the usual help. It's quite useful at this juncture to open and expand each one of the items that are in the list, and also in fact to check on the icons underneath to see what they do. You'll see that GeoDa can do quite a lot, and in particular, and of interest to us today, what it can do is these 7 different calculations relating to Moran's eye, both in univariate and bivariate versions, and indeed using it to compute local statistics with an empirical Bayes estimate of the rate. What we're going to do is to use the SIDS data, sudden infant death syndrome data for North Carolina, and we're going to get those data as a shapefile. So we go to File and Open Shapefile. We then need to navigate to where we have these data available. There are lots of places we could go. Let's go to SIDS2 in this case, open that, and what we get, you'll see, is a map. It's not a very informative map because all it shows us is the geography of North Carolina. And as I say in the notes, it's worth having a look to see which of these 100 counties are the major urban areas of that state. So what we have there fundamentally is the structural, the geometric information about the geography of North Carolina. We now need to populate it with some data and to draw a map based on those data. So if we click on Map, and I'm going to choose a quantile map. That's a map in which the values have been divided such that there is an equal number of counties, in this case, in each of category of the classification. So I'll ask for a quantile map, and the variable that I'm going to map is going to be the number of births in 1974. So that's BIR 74. So I click on that and OK it, and I again get a choice of number of classes. Well, if I choose 4, and there are precisely 100 counties in North Carolina, what I'm going to get is a map in which we have 25 counties in each of the 4 categories. And it's really as simple as that. What I've got is a map of North Carolina total births on a county basis. You can see here on the left the categories that are used and the shade colors that are used. You'll have noticed that I adjusted this limit by simply dragging and dropping. I can do the same for the map itself by clicking on a corner of the map and expanding or contracting it in that way. It's a good idea, incidentally, with map data not to do that or that, because you stretch the map in a particular direction. Whilst this map is here, can we explain its pattern? Is it actually a useful map? Well, if you go back to the notes, you'll say that I claim that this is, in fact, a very silly map. What I'd be interested in is how you react to that view. And I'd be interested in your comments on the discussion forum about the entire issue of whether area shaded maps should be drawn where the values that we're mapping are these absolute totals from 248 to 1035, etc. Actual births. So it's as simple as